My name is Mielias, and we're going to be going over matrices in this video. Okay, our systems are negative x plus y minus 5z equal negative 24, x equals negative 5, and x plus 5y plus 5z equals 0. And the first step we're going to do is trying to get the most zeros at the bottom. So since we already have x equals negative 5, we're just going to put that. And remember that each row counts for a variable. This is x, this is y, and this is z. And this is one of our values. So we're just going to put x equals y, and it does not matter which one you put the other two in, just as long as we have that one and that one, because it makes it much easier. And in the first box, what we try to do is we're going to get the first one. It has to be a 0. Right here. So what we have to do is try to figure out what we have to do, and we always use the row above to get a 0 at the bottom. And what I did was get row 3 plus row 1. Oh, well, yeah. And then it was 1, 0, 0, negative 5, minus 1, plus 1, minus 5, minus 24. Which equals up to 0, 1, negative 5, and negative 29. Now, in the bottom one, we're going to be getting a 0 value for this one. And what I did was added R2 plus R1, which is row 2 plus row 1. And what we got out of that one is 0, 6, 0, negative 24. And that's what goes in this row. Now, on the third one, we're going to go back to the last row, and instead we're going to try to get the 0 for this one, so we could get the triangle zeros. And what I did is did row 2 minus 6r row 3. Remember the 6 you multiply or you distribute to row 3, the entire front, and we get 0, 6, 0, minus 24, 0, minus 6, 30, 174. And what I got with that one is 0, 0, 30, 150. Now for the last matrix, what we're going to try to get are the star step ones. And the only thing we have to do to this one is we just have to divide each row by whatever number we need. So for row 1, we had to divide by negative 1, so it's negative r row 1. And then 6 to get rid of the 6, so it's 1 over 6 r2. And then 30 because it was that one, so it's 1 over 30 r3. And then after that, we have to put back the x and y and z values to get all the equations. So we're just going to start at x minus y plus 5z equals 24, because that was the top row. And then, the only value we have is a 1, so y equals negative 4. And the same for the bottom. We already have the z value, so we just box both the y and the z values. And since we already have these two, we can just plug it in into the top one to get the x value. So x plus 4 plus 5 times 5 equals 24, x plus 4 plus 25 equals 24, x plus 29 equals 24. And we subtract 29 from both sides to get x equals negative 5. And to correct this, or to check and see if this was correct, we're going to plug the original system of equations into second matrix and get the bottom ones, and then we're going to use the RREF to see if we got these three ordered pairs correct. That's how you do matrices.